Okay, so good morning. Happy Tuesday. Those of you that just got in here, thank you for joining us. Happy Tuesday. Again, it's May 11th, so that means we have exactly 1 month left. So before we go on to the classwork for today, because I wanted to do an example of the classwork and then set you free to do the classwork, somebody had a question on number 13 on the finding angle measures homework. So if we look here, we see that this is a right triangle right here, right? Where these are the legs. And this is the hypotenuse, right? Oops. Okay. So what do we need to do? We want to find PS. So we need to know what PS is. So if we look at this triangle is here. That's our right triangle. But we want to know what PS is. PS has nothing to do with this triangle. So what do we do? Well, PS is part of this triangle. And if you look here, that's a right triangle. This is also a right angle because this is a straight angle, right? That's a straight line. So we have, this is 90 degrees. This is 90 degrees. So that's a right triangle. So we actually have two right triangles going on, right? So we'll call this one the big right triangle. We'll call this one the small right triangle. Okay. So we're going to look at the big one. So if I'm looking at the big one, I can use the big, because what happens when you have, usually what happens when you have two triangles in a problem, you're going to use one triangle to get information for the other triangle. So if I'm looking here at this little triangle, I only have an angle. I don't have anything else. I would love to have a side, right? I would love to have a side because this is my X. This side is my X. That's the side we'll call X. That's the one I want to know. So I have this angle and this side that I need to find. I just need another side. Well, if I can use this big triangle to find this side right here, right? So once I know this side, then I can just ignore this triangle and just look at this little triangle and use that, that, and that as for a trig function. So let's try that. So I'm going to call this, well, it's SQ, right? This is SQ. I want to know what SQ is. Okay, and I'm going to find out SQ by using the big triangle. So that's usually what you do. You use one triangle to find information for the other triangle. So if you look here, I have this angle. I want to know this side, and I know this side. So what is that? So I have this angle, and I want to know the opposite side, but I know the adjacent side. So which one's opposite adjacent? So let's remember our sine, cosine, and tangent. That's tangent. Exactly, that's tangent. So let's make that tangent of this angle of 28 degrees equals opposite, that's SQ, we don't know that, over adjacent, which is 39. But mister, why are we finding SQ? That's not what they're asking for. They're asking for PS. Yes, I know, student. But we're using SQ so we can have more information for the small triangle right here. Because I'm going to use the small triangle to find my PS, to find what I want to find. But I need to know the length of that. And this triangle cannot help me find this length, but it can help me find this length because opposite, adjacent. So now let's do that. Let's do that. So I have 39 in the bottom. So what's the opposite of dividing by 39? Multiplying by 39. And so these cancel. So SQ equals 39 times the tan of 28. So get your handy dandy calculator. Where's my handy dandy calculator? Well, I'll just use my phone. And I get, where's my calculator? There it is. There's my calculator. So I get the tangent of 28. And I multiply by 39, and I get 20.7. 20.7. So SQ is 20.7. Yay. So this right here is 20.7. Okay? So now that we've done that, guess what? We can ignore this big one now. We don't have to deal with this big triangle anymore because I want to focus on this triangle. And the reason I want to focus on that triangle is because this is what I'm looking for. This is what I'm looking for. So now, again, we know this is the leg and this is the leg. I can erase all this. I don't have to look at this anymore. And this is my hypotenuse. Okay, so now I'm just focusing on that triangle. So now, this is my angle, 76. And I know I just found out this side. And I know, and I want to find out this side. So I have the opposite side, and I want to know the hypotenuse. So which one is opposite hypotenuse? I know the opposite side because I just found it using that stuff, right? And I want to find this side, which is the hypotenuse. So opposite hypotenuse is sine. Very good. So now I'm going to have my second, and I'll write it over here, sine of that angle, 76 degrees, equals opposite leg, which is 20.7. We just found that out, over hypotenuse, which is x, which we don't know. That's the PS we want to know. And so now I'm dividing by x. We do not like x in the denominator, so I'm going to multiply x to both sides because that'll cancel it out, because I don't like an x down here, so that'll cancel it out. So I get 20.7 on this side, and I get x times the sine of 76 degrees. And so if I want to get x by itself, I will divide both sides by the sine of 76 degrees, by the sine of 76 degrees. Cancel, cancel. So now x is by itself. X equals, put this into your calculator. Put that into your calculator. 20.7 divided by the sine of 76 is 21.3. And there you go. So yeah, so you have the same thing for 14. You got to use one triangle to get a piece of the other triangle, so that way you can use the other triangle. So that's what we did here. We used this big triangle just to get that side, because we really are interested into this triangle. That makes sense? Yeah. Those are the tricky geometry problems where you have to use one, and we've done this before in other things. You have to use one piece of information to get another piece of information that'll help us out. So it's like a 2-for-1. Buy one, get one free. All right, any questions before we move on to today's classwork? So that was the homework from last week. Only 6 of you have turned it in. So please get that in this week. Please get that in. And please take that quiz. If you didn't finish the quiz, go finish it. Or if you need to take it again, go take it again. You can take it as many times as you need to, right? You can only take it 3 times, and if you need to take it more than 3 times, you just got to let me know so I can erase the low ones and you can take it again. But yeah, you can take it as many times as you want. All right, so let's go to today's classwork, right? So for today, remember, there's 2 things we're going to look at. We're going to look at angle of elevation problems. Oh, it's okay. It's okay. It happens. Yeah, my internet was acting dumb yesterday too. I had to just reset everything and everything came back to normal. But yeah, I understand. It's okay. So we're going to talk about angle of elevation problems, and we have 4 problems you're going to do for classwork. Then we're going to have angle of depression problems, and you have 4 you're going to do for classwork. And I put them due on Thursday, so you have today, tomorrow, and Thursday to do them. Okay? So I'm giving you plenty of time to do this classwork. So angle of elevation just means, think of a person's line of sight. Okay? You guys see this word, line of sight? Well, if you're a person just standing there, the first line of sight is just straight ahead. Usually people just look straight ahead. Right? That's your first line of sight. And then if you look up, and now your line of sight is looking at something up in the air, there's your new line of sight. You've just formed an angle of your head going from straight to up forms an angle, and we call that angle the angle of elevation because your head went up. Okay? When looking up at an object, the angle of elevation is formed by an observer's line of sight and a horizontal line, right? The horizontal line is your first line of sight when you're looking straight, and then you pick your head up. Now you've created an angle. Okay, and the same thing happens when you look down, right? Here's your line of sight if you're sitting up high. Oops. If you're sitting up in a high place, you're looking straight, or if you're a plane, right? I know planes don't have eyes, but you got to think of, I'll still have a line of sight. And then if you're up there and then you look down, at something, right? Your head goes, faces down, you've created an angle of depression. Okay, you look up, angle of elevation, look down, angle of depression. So those are the two things you're going to have to look out for in these problems. So let's do number one. Let's do number one right here. Okay, draw and label a diagram, then solve for the missing part, round to the nearest tenth. Okay. Going to remind you, there are 4 steps to problem solving. 4. Right? And this goes for math, but I would argue that these 4 steps work for any problem in your life, even regular old household problems or relationship problems or any problems you have. Right? Because I told you, I'm teaching you math, but I'm also teaching you life lessons, right? How to think, how to be a more critical thinker, how to break things down, how to solve problems. And so step 1 is hugely important. It's understand. So you're going to read the word problem once, and you're going to understand what's going on as a human being. You're going to ignore the math. You're not going to think of any formulas. You're not going to think of solving it. You're just going to say, do I understand what's going on in this situation? Right? And usually you should draw a picture here. Draw a picture or diagram. Okay, that's where usually you do it. You can draw a picture to make sense of the situation, what's going on. You don't always have to draw a picture, but sometimes it's helpful. A lot of times it's helpful. Especially in trig problems, it's really helpful. So understand the problem, understand the situation. Don't think about numbers or math. You can totally ignore numbers. You can totally ignore the math. You can totally ignore formulas. You're not thinking. That's step 1. And that's the important part. Because a lot of you hate math. And you're like, oh, I don't want... You're ruining life by putting math into it. Okay, I'm sorry, but math is everywhere. It's already there. I'm just exposing it. But no, read the problem and don't even think about math. And then step 2, once you've understood it, step 2 is your plan or connection. Now you look at your diagram. Now that you understand the problem, you look at your diagram. Now you say, okay, now what kind of math stuff can I connect to this? Let's make a plan. Is there a formula I can connect to this? Is there a picture in there? Is there a triangle, a circle, a quadrilateral? Is there something that I've been studying that's in this picture I've been looking at that I can connect to what I've been learning in math? And that's where the connection comes. And then once you find that connection and find the formula and go, oh, there's a triangle. Oh, that's a hypotenuse. I thought it was a ladder, but oh my God, it's a hypotenuse. That kind of stuff. You start connecting things. Oh, this is what Mr. was telling us. They gave us this angle and this side, and that's a leg. Oh my God, I thought that was just the side of the house, but that's a leg of a right triangle. Oh my God, there's right triangles all over my house, all over the world. Stuff like that. Then you start connecting. Once you have that connection and you set up that formula or whatever you need to do, then you solve. And then once you get an answer, you check to see if it makes sense. I got an answer that my house is 3 feet tall. Maybe I should go back because I don't think my house is 3 feet tall. That kind of stuff. All right, so let's read this problem. Casey, okay, that's a person. Casey cites the top. Okay, what does that mean, cites? I think they just meant sees, right? Just sees, right? Casey sees the top of a tall lighthouse. Okay, what the heck's a lighthouse? Okay, if you want to look it up, if you don't know what a lighthouse is, go over here and type in lighthouse. And there it is. That's a lighthouse. Those are all examples of lighthouses. It's something it's a big, tall thing at the either on a little island in the ocean or right at the edge of the ocean. And it has light at the top. Have you ever seen this? And it's for ships to let them know, hey, land is right here. Stop. Don't keep coming this way. You're going to hit land. So that's what a lighthouse is. Okay, so you see that? So someone sees the top of a lighthouse. Okay, they're not at the top of a lighthouse. They see. It says sights. I know sometimes these word problems, they word them in the weirdest way. I don't talk like that, mister. I know. That's why you need to look at this and understand what they're saying. So Casey sights or sees the top of an 84-foot lighthouse at an angle of elevation of blah, blah, blah. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? Okay, so let's draw a picture. Okay, so we know there's a kid named Casey. I'm thinking he's a kid. Maybe he's not a kid. Maybe it's an adult because Casey is 6 feet tall. Okay. Oh, don't worry about the numbers. Somebody said, Mister, you said don't worry about the numbers. Okay, I'm sorry. Don't worry about the numbers. So Casey is whatever tall. And then here's the lighthouse. I don't know how to draw. I think there's a lighthouse up here, right? See that? There's a lighthouse. Oh, there's Casey. That might be Casey. You want to just use this picture? I would do that. Let's just use this picture. This is Casey. Hi, Casey. Casey is a certain height. Okay. And so if he looks forward, there you go. And then he looks up at the top. It says he's looking at the top, right? And then they want to know how far he is from the base. So how far is he from the base or the bottom of the lighthouse? Okay. There you go. So we understand what's going on. We got a kid named Casey looking at the top of a lighthouse, but we always can draw a line of sight, right? We always want to draw something that goes directly to the object. So that's this straight line right here. And he looked up, so he formed an angle of elevation, right? Don't worry about that. He just looked up. He formed an angle. When you look up, you just form an angle. And then they want to know how far is Casey from the base or the bottom, right? This is the base of the lighthouse. Yeah, I'm going to use this picture. Whenever you can use something that's already been done, I highly recommend doing that. Why draw your own picture when you have something right here that's basically the same thing, right? So good. So we understand the problem. Got a kid looking up at the top of a lighthouse. This is a lighthouse. How far is he from the bottom of the lighthouse? Good. Now let's start connecting things. So they did say Casey is 6 feet tall. They did say the angle of elevation is 58 degrees. They did say the lighthouse is 84 feet tall. Okay. And we want to know this. So if you look here, Mister, guess what? This and this form a right triangle. Yes, they do. And this is the hypotenuse. Those are the legs. That's a hypotenuse. Exactly. So here's my question. We formed a triangle, but the triangle's up here, right? So how tall is this? It's not 84 because 84 goes from, 84 goes from here all the way to the ground. So how do we know what this is right here? Right? How do we know what this is? We know the whole thing is 84, but how do we know what this is right here of the triangle? Because I want to know this. I want to know how far he is from here to here. So guess what? That's going to be my X right here. That side's my X. Casey, what about Casey? Casey's 6 feet tall, someone said in the chat. Yes, Casey is 6 feet tall. That means from here to here is 6 feet. So that means from here to here is also 6 feet, right? So that means if this is 6 feet from here to here, then what's this? That's 84 minus 6, right? Because you got to take away this 6. This is Casey right here. This is 6 feet right there. So 84 minus 6 is 78. So that means this side is 78. And this side is Casey to the lighthouse. So that's what we're looking for. So now we have all the information. So let's see if we can set up an equation. We have this angle. That's our angle of elevation. That's the angle we're focused on because that they told us that's what it was, 78 degrees or 58 degrees. And so we have the opposite side, the opposite leg, and we have the adjacent leg. Opposite leg and adjacent leg. Right? We don't have the hypotenuse. We don't have the hypotenuse, so it's not sine or cosine. So yes, it's going to be tangent. Tangent of that degrees, 58 degrees, equals opposite, which is 78, over adjacent, which is x. There you go. So there's our setup. So that was step 2. So now that we have our setup, now we can solve. Now we can finally go to step 3 and solve. I have x in the bottom, just like we did a minute ago. We have x in the bottom. So guess what? I don't like an x in the denominator, so I'm going to multiply both sides by x. So these cancel out. So I get 78 equals x times the tangent of 58 degrees. And to get x by itself, I'm going to divide both sides by the tangent of 58 degrees. Tangent of 58 degrees, cancel, cancel. So x equals, punch this into your calculator. Let's punch that into our calculator. 78 divided by the tangent of 58 equals 48.7 feet. So Casey is 48.7 feet away from that lighthouse. So here's what we're doing. Here is what we're doing. We are going to work on 2, 3, 4, 5, 6, 7, 8. Okay? Today, tomorrow, and Thursday. Okay? Is that fair? I'm giving you 3 days to do 8 word problems. I think that's pretty fair. And tomorrow, yes, when we start class, I will go over another one. Okay? So I will open some breakout rooms for those of you that like to work together. And if you have any questions, let me know. Someone said they think a month is more than fair. Yeah, I don't mind giving you a month, but I do have to teach you other stuff, so I'm sorry. Yeah, I know you're kidding. But yeah, if I could, I might, but probably not. A month might a little bit overkill, but yeah, 3 days should be today, tomorrow, Thursday. And today isn't even a full day because we have about 17 minutes left of class. So we're just going to get started.